Hi, can you hear me? Okay, cool. Hi, I'm Mana. I'm going to be your MC for the next couple of talks. And next up, we have James Belchamber and the performance impact of auto-instrumentation. And you can kick it up now.
Right, hey everybody. Yeah, I finished this about 10 minutes ago, so stick with me. Before I do, last year I did this thing where it was my first talk, so I did, hey FOSDEM, and I'm going to do it again because it was really fun, so hello FOSDEM! Woo! And that's the sort of energy that you've got after a whole day and a night. How many people were at Bite Night last night? A couple, okay, so it wasn't just me. Awesome. And if I've got this much energy and you guys mostly weren't at Bite Night, then let's keep that up. Right, so hey everyone, my name's James. I've spent the last year or so in the trenches of an observability transformation. So I thought I'd come and tell you about it a little bit. So I'm an ops guy. I've spent about 20 years now working up from fixing computers door to door. I was a Linux sysadmin, then that became uncool, so I became a DevOps engineer. Now I'm a platform engineer, I guess. And so everything's coming from this sort of perspective. I'm now working with a great software developer who will be referenced in this talk a little bit as well, so we've got that as well on that side as well. You might know me from my talk last year, introducing observability to an airline, so I'm still there. Still plugging away. Look at this guy. He was so young and so happy. So the stack that we built to support our auto-instrumentation needs has kind of evolved into a platform now, and we've some pretty cool things since there. So we have collectors in our base images that are ready to export forward telemetry from to our back-end systems. We've got per team customization on that as well. So we've got a nice suite of metrics that are coming from Node Exporter and Windows Exporter. We do have some Windows instances that we can use for systems monitoring. Notably, by the way, just as an aside, Node Exporter, if you're on AWS, far better information than you're getting from AWS itself, so use that if you can. And we have everything as code as well, which is lovely, including our dashboards, which have key metrics that are vended and updated for all services based on what they're using and what we should be keeping an eye on, following sensible use, utilization, saturation, fine, and errors, and red requests, errors, and duration, guidance for the infrastructure and application layers. Again, this is customizable on a per-team basis. And of course, a lot of this is driven by auto-instrumentation. Am I allowed to swear? Auto-instrumentation is fudging brilliant. Who here has contributed to the auto-instrumentation libraries? I was hoping, that's a shame, that's fair enough. These are cool, and wherever they are, I love them for doing this. This has made our job so much easier. They're basically there, you hate this some people hate this when I say this, but it's basically like pattern matching. It reaches into applications, it recognizes common patterns, mostly functions in frameworks and like the standard libraries, and they write sensible spans to go with that code. So when you auto-instrument a web app, for example, you're not going to get everything. You're not going to get like your custom logic, but you're going to get the connection coming in. You're going to get the response going out. You're going to get like Spring Framework function calls. You're going to get database connections and stuff. You're going to see that all in your spans. It's a ridiculous uplift, and it's basically free. Basically free. Now, some people that I've worked with have pointed out that code needs to be executed, and that uses CPU cycles. These applications, which have been meticulously designed to be as performant as possible, mostly written in Java. So yeah, have you thought about the performance, James? And they're right. James, performance is impacted by auto-instrumentation. Luckily, this is something that I did some testing on. And so for this talk, I fleshed out my knowledge. I did some demos and stuff like this, and this is what I'm going to be sharing with you. So before we go deep, let's do some basic testing on a couple of languages that we can currently auto-instrument. I would like to say that this is not me showing you internal testing with a client. This is me using demonstrative testing that I can use to show what I've experienced. So the stuff that you're going to see up here is not benchmarking. You shouldn't be looking at what I'm showing you today as a benchmark of how these things perform. But it does help us tell the story of what I've experienced over the last 2 years. Let's start with Java. So Java auto-instrumentation is incredibly easy. If you've got Java in your stack at the moment, auto-instrument it. It's so easy. You download the agent and attach the agent, dash agent, and then you attach add two environment variables and restart the application. That's basically it. And like most of these solutions, what it's going to do is it's going to start pouring out OpenTelemetry protocol on 4318, I think by default, to localhost. And then if you want it to go somewhere else, then you can add another environment variable and stuff like that. And we, in this instance, we did want it to go somewhere else. So for all these testers, we're hosting the collector externally. That just means that you'll see a little bit more network traffic, but you shouldn't see any other performance impact from the collector. So to test auto-instrumentation, I wrote a very simple Spring Boot application. This is possibly my first Java application. And it just responds to any request on /hello with hello. Obviously, this isn't quite it. There is some other boilerplate. It is Java. I like Java, but you get the gist. So let's start with the most basic test. We're going to do a get, a sleep, a get, a sleep. So we're running 10 virtual users. We're running over 10 minutes, and we're just going to get my IP address on /hello and then sleep for a second. We won't do this often, but this is just like the demo. And this is what we're getting. So although it looks significant here, like this kind of stuff here, I want you to pay attention. I'll upload these as well. I'm probably run straight out of the camera, but it doesn't matter. You can see here like 5 milliseconds to 20 milliseconds on this. You can see these bars over here. This is all relative, but this is all within margin of errors. So I'm just kind of showing this to you as an example of what we're doing. We can see the manual instrumentation at the top. This is average requests per second. This is the average P99, and then you've got your P99 and your requests. Errors don't come into it actually all that much, so I didn't really need that. That was probably a waste of space. And as you can see, we're not really seeing any difference between auto-instrumentation, manual instrumentation. I asked Mania, who's the software person I'm working with, to manually instrument this Java app that I wrote as well. So we've got no instrumentation, auto-instrumentation, and manual instrumentation. I also installed Node Explorer on the back end, so we can see 1 second sleeps. If you can't see these properly, I will upload them as well, don't worry. So everything hovers around the same place though, except for with memory. This is, what you're seeing here is, this is the weight of auto-instrumentation on the RAM. Of course, we're loading this agent in. But these are on AWS, these are T3A micros. So these are 2 cores with 1 gigabyte of RAM. So, there's not, again, relatively not that much going on here. And of course, you can see over in the network transmit there, we're seeing more, obviously, because we're sending out the spans. But pay attention, these are kilobits. So these are tiny changes. So essentially this is boring, and this was just me using it to show you like what we're doing today. So we're going to remove the sleep now, and we're just going to see what happens. So this is just your simple Spring Boot Hello World application, and as you can see, we've got something really weird going on. So manual instrumentation this is not margin of error. Manual instrumentation is performing weirdly a lot worse than auto-instrumentation and none. So auto-instrumentation and no instrumentation seem to be performing about the same. But we seem to be getting this ridiculous performance impact from manually instrumenting my little application. Let's pin that before you all crucify me. We will talk about that in a second. And again, looking at the instance stats, we're not seeing all that much going on. Again, weird. Manual instrumentation is using a whole lot more memory. But otherwise, this is just the story of a busy server. Let's pin that. Let's go and have a look at another language and see if we can get our bearings on this. Go auto-instrumentation is also pretty easy. Technically, of course, it shouldn't be possible. The way that auto-instrumentation works is it tends to attach to like a virtual machine or an interpreter, and it adds stuff. And how do you add stuff to a completely compiled application? Well, you use eBPF. eBPF is really cool. I'm not really going to talk about that too much here, but it's very much work in progress, this at the moment. I think they introduced a beta release. Is that true? Yeah, a couple of days ago. So do look at Go auto-instrumentation. But again, you compile it. You do have to compile it currently. Upload it to your server. The way that it works is that it runs as a separate application and it looks at the application you tell it to, which is different. So again, Gin application. I asked Manu to write this again because I don't know Go. We'll see how this performs. So again, sleep 1 second. We're not really seeing much. These are the razor-thin gaps. This is just margin of error. And with sleep 1 second on use, again, we're not seeing crazy amounts of differences between it. So let's go straight to the no sleep. That's the interesting bit. And this is more like what I would expect to see than when we saw with Java manual instrumentation, is that we would see actual, differences, sometimes significant, sometimes not. Again, this isn't crazy significant. In fact, it's the auto-instrumentation that's performing the worst here. We're looking at 5 milliseconds versus 10 milliseconds. Like, that's not crazy big gaps. So yeah, we're seeing a significant drop-off in requests per second as well. And again here, like, we're seeing server busy. We are again seeing auto-instrumentation using more memory than manual instrumentation, but these are for relatively small differences. Okay, that was a lot of taking screenshots of Grafana and passing them off as slides. So let's go and look at some lessons that we can learn so far from this talk. So we definitely 100% know that they were right to suspect that code, upon being executed, does use resources. We also know that manual instrumentation uses resources. Okay, I'll get to the serious insights. One thing I didn't tell you is that Manya, being a great developer, is not a Java developer. Another thing that I didn't tell you is that we did this incredibly quickly. So we basically just got this application working and we just left it there and we started doing testing. Manya is a Go developer. So the manual instrumentation of our little Go application, although implemented just as quickly, was dripping with her previous experience. Like, she knew how to write Go applications. And so this is the old adage, right? It's like how assembly can be more performant than Python. And that's true, but can your assembly be more performant than your Python? We did actually go back and rewrite the Java code. And I did this mostly because I didn't want anyone that was working on that project to think that I'd misrepresented them. And as you can see, once we worked out what was going wrong, that we reran the tests, and now auto-instrumentation is performing about the same as manual instrumentation. But it was a great example of how manually instrumenting an application can catch you out, just like with any software development. This is the instance stats for posterity. Again, I'll put this in the slides that I'll upload in a bit. And you can see how now manual instrumentation is slotting in right between auto and none, which is the kind of thing we'd expect. So auto-instrumentation, by comparison, is much more consistent. You definitely can squeeze more performance out of manually instrumenting an application. But honestly, even if you can, at the expense of maybe getting caught out and bringing out bugs and stuff like that, it might not matter. What we might have built there was possibly one of the most simple applications that ever served a HTTP request. I'd wager that more resources were spent on creating and shipping a span for each request than actually serving the request itself. So what we've explored here is certainly interesting, and it's given us some basic orientation on the performance of auto-instrumentation. But I think it's time for us to start looking at the performance of real applications. I did say real applications, but I'm going to start with Pet Clinic. Pet Clinic is you've heard of Pet Clinic? I heard a couple of giggles, so yeah. Giggles, laughs, manly laughs. Pet Clinic is an example application written in Spring. It's a bit clunky, a bit slow. It has cute pets. I mean, it's basically a sample application that allows you to learn the tooling right. And it's kind of a pretend CRM system for vets. So we're going to instrument this. We're going to script some interactions this time. I'm not just going to do the one thing. I think I did like 17 different requests across the system. Searching, browsing, and form submissions. We'll see how we do. Now, the first thing I'll note is that I started with what I thought was a fairly lightweight test. But again, we've got this very simple server, and we've got this Java application that can't really handle that much. It's not designed to be performant. And 20 virtual users working through 17 different interactions, it struggled, as you can see. Errors bars started actually coming up here. So yeah, auto-instrumentation. I mean, is auto-instrumentation making a difference to this application? No. No, like 324 versus 326 requests. Like, this is, I mean, an application that's under a huge amount of load, but like, we're not seeing the kind of gaps that we were seeing before. But maybe that was just because I put it under a huge amount of load. The reality, and this is, by the way, the instance side, the only difference here really is in memory. It's worth saying that Pet Clinic uses an in-memory database, and I only gave it a gigabyte of RAM, so it didn't quite run out, but it was struggling. Let's lower the pressure on this, because let's be fair, even if this was a real CRM for vets, you'd have maybe 3 users making 5 requests a day. So, like, this is one virtual user, and this is our red testing. And even then, like, when we're taking off the pressure, what you can see here is, and this is what I've seen in reality, the measurable differences from our basic testing, from our performance testing, from our, all of that stuff, they're gone here. We're actually seeing that auto-instrumentation has very negligible impact. And again, on the back end, again, RAM seems to be the only thing I ever see with auto-instrumentation, a little bit more RAM. Again, that's like 60 megs, right? That's like a gig to play with. And so this brings us to lesson 6. An application that is actually doing something more significant than just serving a simple response on an endpoint is probably only going to be negligibly impacted by auto-instrumentation. Or really, indeed, manual instrumentation that's been done well. Going to go through a couple more, and then we'll move on. Let's pick something that's real, that's doing less. Did you know that there's a module you can add to HTTPD that starts pouring out spans? It's good. And of course, HTTPD is like a C++ application, so that's really cool. I don't know if it's auto-instrumentation. I guess it's just instrumentation. But I did one pass at this quickly. Turns out that I had to turn the errors. It's going to hit the just it works page. You loaded up Apache HTTPD and does it works? That's a 403. Who knew? And yeah. Whew. So this is HTTPD just responding with the simple, HTML page, it works. And as you can see, that we're adding an order of magnitude more on top of that in terms of response times. And we can do three times the throughput without auto-instrumentation versus with auto-instrumentation. And at the back end, the disk was much more aggressive. Interestingly, I think that I could do a lot of tuning here because I think that it was writing a bunch of logs that it didn't need to write. They weren't errors, that's just by default what it was putting there. And this only had 8 gigs of disk space. So I suspect there's tuning is possible. But this kind of represents the fact that you should really be thinking about what your applications are doing, because if you've got a HTTPD instance there that's just meant to be very quickly responding to like static requests, that's an example of something where you might see an impact. But this is not how people use HTTPD, is it? People use HTTPD to host WordPress and then argue with each other. Let's put WordPress behind this and try again. You can see here that I ran WordPress with and without, I could have chosen better labels for this, with and without HTTPD instrumented. And then I instrumented WordPress itself with PHP-based auto-instrumentation, the rare double auto. And as you can see, like here, like with the big gap that we saw between HTTPD being auto-instrumented and not auto-instrumented, that basically disappears here. And actually, it's the PHP-based auto-instrumentation that you start seeing having a problem. Not significant. I'd say that I'd still be happy with that, personally, because I think that it's worth it. We'll talk about that in a second. I'm not entirely sure what's happening here, but I will note that for each request to load the sample page on WordPress, it created 35 spans. 22 of those spans were database queries. This is for this single sample page. I don't understand WordPress. But yeah, otherwise everything looks pretty much within margin of error. And honestly, that's not, I've done WordPress hosting, and that's not what people worry about, right? When you're doing WordPress hosting, you're thinking about your caching efficiency. So again, you see that performance impact and you go, oh no, big performance impact. And then you think about your application. Well, actually, most of your WordPress applications, yep, 10 minutes, I'll speed up. Most of your WordPress applications come from caching, you're looking at caching efficiency for your performance impact. But it does underline the need for good performance testing, which you should be doing anyway. But when someone asks me, what will the performance impact of auto-instrumentation be, my answer is well, test it. Because it does depend on your application. And most of these, auto-instrumentation stuff, it's been pretty easy to instrument. So the harder ones with the HTTP module, had to spend a bit of time on that. And WordPress, because WordPress doesn't install with Composer, and the auto-instrumentation installs the Composer, but you'll work it out. But yeah, the little bits do add up. So yeah, get into performance testing your applications, and now is a great time to start. Okay, so far I've been relying on you, dear audience, to believe me when I say, hey, all of this is worth it. But I would like to label a little bit on why it's worth it. Firstly, looking at applications in terms of traces. Even if you have the most perfunctory span, and most of your application is just custom code, you're still going to get the request span, you're still going to get things like the database calls. This is actually an example that we had from a real application with our client. This isn't a real trace. Grafana Tempo doesn't output this. But this is a representation of the problem that we had. We had an application that had a huge amount of custom logic, and we were basically not seeing anything, even with auto-instrumentation. But we did know that one of the things that we were being told is that the application that we were running, that they had developed, was slow because our database wasn't performing as well. We were hosting the database, and our database wasn't performing well enough. And of course, databases never perform perfectly. So of course the database engineers went off and they tried improving the response times on the databases. And they could see that there were some slow queries and things like that. But from the traces we could see that when we got very long requests that were causing us problems, we were getting very short database queries. So we were able to flip the script on that problem and to be able to say, hey, yeah, we know that there are slow queries, but those slow queries are not connected to the slow requests in your application. And this was because it was a Java application, so we could just auto-instrument it. It was incredibly easy. The other thing is automated metrics. A lot of, especially older applications, aren't outputting the metrics that you need to be able to do proper red dashboards. And even if they do, they might be wrong. With auto-instrumentation, you can pull all of this out, and we could create dashboards that upper management had been asking maybe for years, and they were not being put ahead of, feature requests and stuff. It was very easy with tracing to go and generate metrics from that. There's also things like the service graph. I'll get through this very quickly. You've seen this in other things, but I never really understood the value of this, because I was just like, well, it shows you how your application works, but you know that, right? But of course, with a lot of enterprises going back to maybe 60s, 70s, 80s, 90s, they've got stuff that was developed, that was out-developed maybe 10, 20 years ago, and only very few people actually understand what's going on. And to stay understanding what's going on, they have to work very broadly instead of being able to get deep on stuff. Traces just give you this map of everything and corrects everyone's understanding really, really quickly. And even when you've got applications that are not instrumented, where you can't auto-instrument and you're not able to go and manually instrument them. There was somebody in the last year that was doing COBOL. Does anyone here do COBOL this year? Yeah? Pointing at someone else. Are you grassing on them for using COBOL? So yeah, there's no instrumentation library for COBOL, so far as I know, but you can inject the context for the trace into the application, which means that you can go, oh, it went off to this application, I can't see a traces for that, but I can click a button and see all the log lines that match it. God, that's useful. And as we've seen from our experiments, the performance hit is not really apparent at the scale of whatever most applications are doing. You should be doing performance testing. But if you don't have any of the things that I just listed across your whole estate, you should be leaning towards auto-instrumentation. You should be leaning towards picking up these libraries, testing them on your systems, implementing them, and getting them out there, because there's not much of a reason not to. It's free observability, and it's so useful. I do want to talk about manual instrumentation for a moment, because you might be thinking that what I'm telling you here is don't do manual instrumentation, only do auto-instrumentation. It is true that manually instrumenting code is a ton of work. This, for example, is a simple application, and all the bits in yellow are bits that you need to do to instrument your application manually. Of course, this is unfair as an example, because of the more complexity you have to your application, the more code versus other stuff that you need. So the balance would change. But this is still a ton of work, especially on instrumenting existing applications. Doing it for new code is really, really easy. You should just do it. Just start doing it. Just start. The other problem is that humans, of course, create bugs. They also fix bugs. And they also create bugs. Auto-instrumentation has already been written. It's been tested in a lot of places already, and the bugs have been worked out to varying degrees. Some are more further along than others. And of course, because it's open source, you might find it easier to fix the few problems that you're having in your auto-instrumentation than you would in debugging your application and getting it working without manual instrumentation, which of course is the beauty of open source. And the other thing is that auto-instrumentation, you hate this slide, don't you? I've not found a better way of explaining it than this, frankly. The reality is auto-instrumentation is awesome. It's fudging awesome. But it's also reasonably dumb. It's essentially doing pattern matching under the hood. It's finding things and decorating them and stuff. Loads of people are going to come up to me afterwards and be like, it's not that, and correct me, please do. But it's guessing at what attributes should be and shouldn't be added, and of course that's not going to match your application. And so how well it works is going to depend on whether you're mostly writing custom logic and custom code, or whether you're mostly leveraging applications that have already been auto-instrumented. So it's kind of like the bus that you're going to get almost to your destination while you're still working on that custom rocket engine that's in your garage. The rocket car isn't ready yet, and the walk from the bus stop isn't that far. That sounded so much better when I wrote it down. And with auto-instrumentation, you can start your observability journey now instead of waiting. Remember, observability isn't tracing. Observability is a different way of working. Instead of your telemetry being something that you design and then answer no question, instead of telemetry being something that you design in to answer known questions and then implement as part of your software development, telemetry becomes something that you implement to expose the internal state of the system. And then you can start asking questions of it outside of that loop. You really want to get to this for two reasons. One, it's going to be a bionic arm for your troubleshooting. But secondly, it means that everyone else has got this capability as well. They don't have to ask you what's going on in your application. They don't have to ask you to implement that new counter. You can just say, no. The traces are there. We've made sure that the attributes are all there, and just go and pick it out. Right, have I got time for miscellaneous? Okay, really, really quick. Okay, firstly, AWS Lambda. AWS Lambda works, so if you're using that, the only thing is that by default, the AWS version distribution of OpenTelemetry includes the collector in the Lambda layer. If anyone works on Lambdas, you'll know that one of the things you want to do is you want them to start up and complete very, very quickly, and having a whole collector start and then stop again adds a huge amount of weight to that. I would recommend adding an external collector and having it sent to an external collector again. Your mileage may vary, but this is something that's really important when it comes to performance of auto-instrumentation. The other thing is Grafana Baylor. Well, I'd say generally eBPF. eBPF is awesome. As we could see with Go, it was your only option. With C, C++, with Rust, it's going to be your only option for getting traces out. But it gets you less unless you configure it. That might change as we go on, but at the moment, if you use eBPF-based auto-instrumentation, it will give you less in the way of spans, it will give you less context. Someone will come up again afterwards and correct me on that, and I'd love to see it. But my experience is that it's giving you less, and also it's about as performant, maybe a little bit less sometimes, maybe a little bit more. So my approach is still to use traditional auto-instrumentation where you can use it, and to use eBPF where you can't. Again, I've got this is just for posterity, you'll see this afterwards. So yeah, these are our lessons. You should probably be using auto-instrumentation. Time is up. You should probably be using auto-instrumentation. So I'll just say at the end there, we are looking for people, community-led projects that want to leverage this kind of stuff. We've benefited a huge amount from this, so we want to give back. So if you're running a community-led project, open source project, come and talk to us. We'd be really happy to help out, because it helps us out with some experience as well. So
maybe we can give 1 minute if somebody has a question.
Is there any questions, or did I perfectly answer it? Oh, there you go.
Okay, thank you for the presentation. So in my experience, auto-instrumentation tends to create a huge volume of traces, metrics, logs, which in the end cause costs for the storage of those that are sometimes one order of magnitude higher than the cost of running the application itself. So how do you handle, like you should, what are the strategies to reduce the costs?
Okay, strategies for reducing cost. How much do I want people to hate me? Fuck it, don't use Datadog. So what we're using at the moment is we're using Grafana Tempo, not an ad, but it sends it straight to S3, so you get this ability to do all the things you can do with S3 to store this stuff, and you can use any other backend as well. Storage of spans doesn't have to be expensive. I think that's just a choice that the industry made. But the other thing is, yeah, once you've gotten to the case where you're spending, we're just not spending that much. I think, I'm not going to quote a number, but we're spending like 0.01x what we're spending on running the applications, and we're using auto-instrumentation. So, and all I can tell you is that the way that we've done that, the strategy was saving money by using a tool like Grafana Tempo, which pushes it to S3, which gives us those economies of S3 rather than the economies of maybe something like, Datadog as an example. And very specifically, I do call out Datadog because many people have come to me and said, we love this idea, but we don't do it because it's so expensive, and I find out that the reason is that they're using Datadog. If you're listening, Datadog, lower your prices.
Thank you, James. I think that's it. We're